NQL is about more than just queries. Like SQL, it can create, read, update, and delete. Let's take a look. Inserting a new document using NQL is very similar to SQL, but not identical because of the basic architectural difference between relational and document databases. Couchbase is a key-value system at its core, so new documents are inserted along with their key. The values clause takes first a key up to 20 bytes in length, which is about 250 UTF-8 characters, then a value, which would normally be a JSON document. If the key already exists, you'll get a duplicate key error. And yes, we do provide cluster-wide counters and a UUID generating function to support unique key generation where it doesn't otherwise naturally exist for your data. Where necessary, you can use the returning keyword to get back data following the insertion. In high-speed ingestion scenarios, it's not always efficient to check whether a key exists before deciding whether to create or update a record. Under the hood, Couchbase is memory first and append only on disk writes. So the question of whether a key exists is easily automated into the upsert operation, unless you explicitly want to receive duplicate key errors for their logical value. With an upsert, if a key exists, the document is replaced. If not, the document is added, just as if you'd performed an insert. The result is higher ingestion speeds and simpler code for appropriate applications. Of course, there are also times when explicitly updating particular document fields is precisely what you need. So NQL provides an update operation that works analogously to SQL. It lets you set new values for particular fields. You can target documents for updating by filters or explicitly by keys. Architecturally, it's worth knowing that the full document is replaced with the changes you specify. If you explicitly want to change only portions of an existing document, generally to avoid passing large documents across the network for small incremental changes, we provide sub-document manipulation features in our SDK, though these would be performed via API call, not using NQL. Deletion is completely straightforward. You can delete documents by filtering or by explicitly referencing one or more keys. So as we keep saying, you already pretty much know this stuff. But it's worth asking, do you have to use NQL to use Couchbase? Well, no. Our SDKs provide get, insert, upsert, replace, and remove operations that cover everything we've just seen you can do with NQL. And you also have the query operation. It's up to you which approach you prefer for data manipulation. So what have you learned? Couchbase is different in some ways. So you insert a unique key and JSON document as values to a bucket, rather than a list of values to a list of columns in a table. Our memory first and disk append architecture mean we only give you duplicate key errors if you want them. Otherwise, you can upsert documents rather than insert, to insert or update as appropriate based on whether a key exists. We update also, letting you set new values for specified fields, though under the hood this remains a full document replacement. True subdocument manipulation is available via SDK operations. Delete does what you expect, and you can target documents for manipulation by any of these operations by either filtered references or explicit keys. So, again, you pretty much know this stuff. Or, you can also always use direct SDK operations to get, insert, upsert, update, or remove documents. This lab will once again provide some explicit hands-on practice with what you've learned to cement your learning and provide a playground for your own experiments. Next up, we'll be talking about joins. In a relational database, they're mandatory and an embedded aspect of the fundamental data model. In a document database, they're a feature available to support appropriate data models. Come on back.